Hello, this is Amir Shahata with another quick tip on the LUTF. In this video, we will take a 5-minute tour over how the LUTF directory is structured and how to configure it. I have written a step-by-step walkthrough on how to build and deploy the LUTF. Please go to the link provided here or in the video transcript on the wiki for more details. Once you have the Lustre Tests RPM installed along with other Lustre RPMs, you can see the LUTF installed in the standard Lustre Tests directory as shown on the slide. The LUTF directory structure is fairly straightforward. The top-level directory contains the LUTF binary and a set of other generated shared libraries and Python files. These include the C Python wrappers, which the LUTF Python scripts use to call the C APIs. Let's look at an example. You can see here two files of interest, underscore lnetconfig.so and lnetconfig.py. The .py file is generated by Swig and enables the LUTF Python scripts to call the libelnetconfig API. The .so file is a shared library which includes the glue code that implements the libelnetconfig API calls. Configuration scripts are under the Python config directory. These configuration scripts set up all the different elements required to run the LUTF. Various infrastructure scripts which implement the remote script execution feature as well as other LUTF features are under the infra directory. Lustre and LNet specific infrastructure scripts such as scripts to clean the test setup and configure LNet are located in the tests infra directory. Finally, all the various test suites are located under the tests directory. At the time of this recording, the shown test suites are available. The LUTF requires a single YAML configuration file which specifies its environment. Let's briefly explore the configuration parameters. If you remember, I mentioned that the LUTF can run in master or agent mode. Some parameters are relevant to the agent and not the master, although all parameters can be specified. On startup, only the parameters which matter are examined. First off, let's look at the shell parameter. It defines how the LUTF will run. There are three modes it can run in. First, the interactive mode. In this mode, you can access the Python shell. You can do everything you would normally do from a regular Python shell from there. Second, the daemon mode. As the name suggests, the LUTF will run as a daemon process. However, its shell can still be accessed by telnetting to it. Finally, the batch mode. Now this mode is unique to the master and it basically runs all the specified tests and then shuts down. The agent parameter tells the LUTF if it should run as a master or an agent. Node name specifies a symbolic name for the node. It can be any alphanumeric value. The LUTF agent will need to know the master's IP address or host name, which it will use to connect to the master. A symbolic name is also provided to associate with the master. The LUTF will require a port to listen on for incoming connections as well as a port to use for the telnet server. This is what the LUTF YAML configuration looks like. A couple of other parameters relevant to the master node are the suite. This defines a suite name to run when in batch mode. If nothing is specified, the LUTF will run all available suites. And the script. This defines the script name to run and it's only valid if a suite is provided. Both the suite and the script names can contain wildcards, which define a group of suites or scripts. You can follow the shown link for more details on the configuration parameters. Before I leave this topic, I just want to remind you that the YAML configuration file will be automatically generated for you, as I'll show you later on. We're almost ready to run the LUTF, but first, just a quick note on a couple of important naming conventions. All test suites under Python tests directory must start with the literal suite underscore, and all tests under a test suite must start with the literal test underscore. Otherwise, the LUTF will not pick them up and you won't be able to run them. In the next tutorial, we will run the LUTF and see what it has to offer us.